Good evening, everyone. Is my voice audible? Could you please respond in chat box? Thank you. Thank you. Hope you are doing well. Due to some issues, our resource person is joining the meeting a bit late. So you can review the previous session's topics meanwhile for time being. I hope I am clear that a resource person will be joining shortly. So till then, please review the previous session's topics. Thank you. Yes, we have class today. Thank you. Good evening, sir.
Good evening, guys. It's Naveen joining the call. Can you guys hear me? Great. Thank you, guys. Sorry about the delay. Hope you can see my screen also, guys. Great. So, we'll continue our journey today, a little bit on Python. And good evening again to everybody. And sorry about the delay, guys. We had two issues today. One is a meeting we have with one of our US clients due to the Christmas time. A lot of guys in US, they're on vacation. So a lot of work is being need to be taken care of. That is a slight delay, and it also looked like we had some power cut in the central office, guys. Can everybody hear me fine, guys? Okay, it looks like some of them are hearing me low, so just try to check at your end also, guys. A lot of guys seem to be fine, and there you go, guys. So, pardon me. Okay, let's get started, guys. Hope you can see my screen. And today we'll talk a little bit, we'll dig a little bit deep into the basics, basic data structures of Python. We'll continue our journey. Probably the next 1 or 2 days, we'll dig a little bit deep into the basic data structures. Then we'll go into slightly advanced data structures, which is a NumPy and the pandas in the coming up days, guys. Okay. And so let's get started here. So sequences, guys. Sequences, what are they? There are some of the objects, some of the data structures which are referred as sequences. They are nothing but basic data structures. What do we mean by that? We'll try to understand that in a moment. And they are index based. Okay, they are index based. They start with a zero based index. So what is 1 for us is 0 for Python, because Python follows a zero-based index. These data structures follow zero-based index. And here are some built-in types. Some of them are lists, some of them are tuples, some of them are dictionaries, some of them are sets. These are the things we'll try to understand them. Okay, so a little bit of theory before we go into them. What can we do with these kind of objects? Well, they all work like sequences. You can access the elements or objects in these sequences one after one. That's why they are called sequences. You can access them in a sequential order, and we will see that in a moment. We can index them, we can slice them, we can add them, we can modify some of these objects, and we can also try to find which is the what is how many objects are there in these sequences, what is the largest, what is the smallest, and there are other kinds of operations that we can perform, guys. They're very versatile. So in other words, lists are one of the basic data structures that Python supports. They're supposed to be very versatile. They can hold the numeric data, they can also hold the textual data. We, we use the syntax comma separated or the square brackets, and the elements inside are comma separated. We'll look at the syntax in a moment, guys. They're homogeneous data. To be more precise, they're heterogeneous. Heterogeneous means we can have a combination of numerical and textual data, guys. So let's get into a little bit of action here. Here we go. So to start with, if you recall, a equals to 1, This is like an object, just a quick refresh. So if you see what is inside A, you have a 1. So what is this? Jupiter. This is Jupiter. Jupiter is a web ID. And say come here. As simple as that, guys. Next, move on to the next one. Type, if you recall, type is tells you what is the data type. So this is numeric. More precisely, this is non-decimal. Non-decimal is referred as integer in Python, guys. Then we'll look at text. B, Mera Bharat Mahan is an example of textual data. And if you say type of B, tells you it's a string. String is nothing but textual data. Some of the basics from yesterday or from Saturday's session, guys. Now here comes a slightly complex object. Think of this as my list. My list is a group of objects, is a group of numerical data. So here's my underscore list. Ask it what is there. There are like 3 objects inside that. 3 of them are numerical data. And now if you say what is type of my underscore list, it tells you it's a list object. Just like we have integer for numeric data, string for textual data, list is a group of objects, is what it is. So what is list? List, we use the square brackets, they are comma separated values. Okay, let's dig a little bit deep into it. Take a look at this. Here is another list. And what do we have? Well, we have 3 textual data, Nescafe, Brew, and Sunrise. Okay, so what is this? Inside a list object, you can have numerical data. You can also have textual data. Everybody say with me so far, guys. Can you give me a quick yes, please? Now, come back here. Take a look at this one. Here is another list, which is a combination of numerical and textual data. So it looks like from the above, they are homogeneous, but you can also have heterogeneous data. You can not only have numerical data, you can also have textual data, is what a list is, guys. It's heterogeneous. Now take a look at this. A equals to 100, B is 200, C is 300. So there are 3 objects, 3 numerical data. What can we do? Okay, I think what I was trying to find, underscore list 4 equals to, you can create a list object like this, A comma B comma C, and then if you see what is inside that one, you should have 100, 200, and 300. So in other words, this is how we create lists. We use square brackets. Have 100, 200, and 300, guys. Let's move on to slightly deeper. Take a look at this. This has Nescafe, Brew, Cappuccino, and Mocha. Okay, so here is my list. There are 4 coffees here. And now take a look at this. You say my list of 0. It will give you the first one, first object. So what is this? 0 is 1 for Python. It is following a 0 based index. When you go from left hand side to right hand side, it follows a 0 based index is what it is, guys. And let's see what else we have. Take a look at this. My list 0:3. Increasing the complexity a little bit, guys. Take a look at this. Now notice there are 4 cups here. We're saying 0:3, which is like you're asking this one, give me 0, 1, 2, 3. But what is happening is 0 is inclusive, 3 is exclusive. 1 is inclusive. The left-hand side index is inclusive. The right-hand side index is exclusive. So even though you're asking, hey, give me the cups 1 to 4, what is happening is it's just extracting 1 to 3 because the last one is exclusive. The one on the right-hand side is exclusive. Everybody with me, guys? The mantra is inclusive and exclusive. The right-hand cup, the right-hand side index is exclusive. It does not give you that one. That is the syntax that Python follows, guys. Now take a look at this one. My list of -1, notice what you're getting is you're getting mocha, which is the last cup. So what is happening is what minus does is minus is not going from left hand side to right hand side, where it is coming from right hand side to left hand side. That is the first mantra. Second mantra is when it is coming from reverse, it follows a 1 based index. It does not follow a 0 based index. That is what is happening, guys. That is why it is picking up mocha. Everybody with me, guys? Quick yes, please. Okay, so let's dig a little bit deep. Now come here, my list colon, my list of -2. It's like you're asking it from minus means start from back, reverse. And it's following a 2 based index. So 2 is the last second cup, is the last second object. Okay, And let's see, now take a look at this list of 2 colon. So this is like what's happening is if you take my list, what is inside my list? You have Nescafe, Brew, Cappuccino, and Mocha. You say 2 colon, what it is doing is 2 is 3 for Python. From 3, left hand side is inclusive and you don't have anything on the right hand side. That means from the third till the end. That is what is getting copied and pasted here. Okay guys, in other words, one more time, let's say, copy this one, paste this one here, pull up here, bring this up, and let's say visualize, this is your list. This is like a tray. There are 4 cups in the tray. For the sake of simplicity, here is Nescafe, here is Brew, here is Cappuccino, here is Mocha. When we do my list of 2 colon, visualize something like this is happening. It is copying this one, pasting it. Even though we're doing a cut paste, you visualize as if a copy and a paste is going on. That's a copy and a paste. And what is happening is this becomes a new list object, which I'm indicating it as a tray. It becomes a tray of 2 cups is what we can think of. So again, the mantra, left hand side index is inclusive, the right hand side index is nothing, so it is going till the end and extracting them and giving you a new list. Everybody with me guys, quick yes please. Okay, let's go a little bit now. Take a look at this reverse colon 2. So let's say come here, colon 2. Notice you're getting Nescafe and Brew. What's happening is if we come back here, put back that one, and we did a colon 2 here. So what's happening is let's say come here, let's choose this one, we'll strike this here, we'll say my list of colon 2. So again what's happening is, come here just so that it is a bit more clear, let me come here, let's put a space here, let's put a space so that you can see it. So the left hand side index, nothing is there. If nothing is there, it will start from the beginning. And the right hand side index is exclusive. 2 means 3 for Python. So it looks like we're asking from 0 to 3. So what will it do? It will not give you the third one. The third one is not taken. So what is it doing? It's extracting Nescafe, copy and paste it there. Extract Brew, copy and paste it there. That becomes a new list. Okay guys, so take a look at this. There is Nescafe and Brew. So again, one more time the mantra, left hand side index is inclusive, right hand side index is exclusive. That is what is going on here. Okay, everybody with me so far? Quick yes please. Good. Let's see what else we have. Take a look at this length of Mera Bharat guys. And let's see, scroll down here. So if you notice Mera Bharat is a textual data, is a string object. What is happening is when you say length is you're asking like, how many items are there. So kind of visualize it something like this. So Mera Bharat, it's like an object for the sake of discipline in your RAM. This is how it is. It's a textual data, sits like this. But behind the scenes, something like this is going on. Visualize, say choose this one. Visualize the tray. Here is M. This will be in 1 cup. Here is E. Here is R. Here is A. And you continue to visualize like that. When you say length and you ask this cup, what Python is behind the scenes is doing is it is going to this list object or this tray object. For the sake of simplicity, I'll call that as a tray. It is counting how many cups are there. How many are there? There are 12 cups. What does that mean? There are 12 characters in that cup called Mera Bharat. So what is textual data? What looks like a textual data, Mera Bharat to you, is like a single object is really a group of objects behind the scenes, is what it is. Everybody with me guys? Quick yes please. That is how the string is working guys. For the sake of simplicity, let's assume that. Now take a look at this guys. You come back to length of 100. 100 is numerical data. Notice what happens, it gives you an error. So what's happening is, if you come back here, do a little bit of this one. Here is textual data. Textual data behind the scenes acts like a list object, a tray object. More precisely, it's a sequence, is what it is. But when you come, let's take 100. 100 is also acting like a single object, but behind the scenes, it is not a tray. It is not a sequence. It is just a cup. When you ask it, hey, how many, what is your size? What it is doing is you're asking the cup how many cups are there, and the cup does not understand. The object does not understand. Only a group of objects. If you ask an object which is representing a group of objects which is like a tray, which is a sequence, only that can tell you how many cups are there. So what happens? That's why giving you an error. In other words, numerical data, 100 does not get it. Quick yes, please. Is space also included? Yes. Space will come under textual data. Short answer, yes, guys. Now come here, take a look at this, guys. Back to here. Length of 100. We're taking the 100, put that in a single quote, now run it. What is we get a 3. Remember, if the data is inside a single quote or a double quote or a triple quote, it's textual data. That is why. What is this one? This looks like an object, but behind the scenes, it's a sequence. It's like a tray of objects. It's a group of objects. So now it's going and asking the tray, hey, how many objects are there? And that's saying there are 3. 3 cups or 3 objects in the tray. Okay. Back to my list. You ask a list. How many? So here is one more time my list. We have Nescafe, Brew, Cappuccino, and Mocha. You ask it, how many objects are there? There are 4 objects there. List is understanding. Okay. Next, let's say, take a look at this one. This is called an empty list. As simple as that. It's like an empty one. There is nothing in it. You say length of empty underscore list. It says 0. There's nothing there. Then you have integer list. That again is just an example of how you're creating a list with 3. You say length of integer underscore list is 3. So in other words, more precisely, I'm just trying to get you familiar with the length function. Length is a built-in function. Everybody with me, guys. Quick yes, please. Second here. Okay. So it looks like I'm jumping into a little bit of NumPy. We'll revisit the lists again. Okay, I'm going to increase the complexity, guys. I thought I might take a day to come here, but it looks like I'm already here. And for that, let me come back here. I'm going to just pause my screen for one moment, guys. Sorry about that. I have a few other slides here, which I want to just put on the top. So here is the sequences, tuples. We'll save these things for a moment. Here comes NumPy. So this is sets, sequences.
Excuse me, sir, we can't see your screen.
Yeah, one moment.
Okay, sir.
There you go. Sharing it again, guys. Okay. Hope you can see my screen, guys. Quick yes, please. Great. So let's increase the complexity a little bit. And let's come here. We'll try to understand a slightly sophisticated data structures, which is part of the NumPy package. So what is NumPy? NumPy is a package. NumPy is a library. And what is the advantage of it? That's what we'll try to understand. NumPys are arrays. In other words, Python does not have arrays. It has list objects. What is a list? List is like a group of textual data and numerical data. You can have only numerical data. You can also have only textual data. But arrays is something where you can have only numerical data or textual data. It will force you. If you try to put numerical and textual data, it will give you an error. They are for one of the fundamental aspects of scientific computing. In scientific computing, we use this package heavily. It provides us a lot of sophisticated functions. We can also call the C, C++, and Fortran functions, or in other words, indirectly, The NumPy packages are using some of the C and C++ functions, and you can explicitly call them. Some of the functions include linear algebraic, Fourier transform, random numbers. These are all the sophisticated mathematical functions which are provided as part of the package, and we don't have to redevelop them. We don't have to write them again from scratch. They give us also what is called n-dimensional arrays. What is that? We'll try to understand that in a moment, guys. Let's come here. They are homogeneous. As I said, you can just have numerical data, you can just have textual data. The main advantage of NumPy arrays is they are super fast. They are faster than lists. More precisely, they are super fast. Speed is important, especially when you deal with large amounts of data, especially the machine learning algorithms and things like that. A lot of slicing, dicing, and things like that. The speed becomes important, guys. We can also have nested loops or list comprehensions. We can write that kind of a code. We'll see what that means, and it allows us to write what is called array-oriented programming, guys. So, what is array-oriented programming? That's what we are going to get a touch of it. So let's see what we have here. Here is the data, and data equals to np.array. This is how we create an array. So what is this one here? We're taking a list object. Let's say, come here. We're taking a list object and we are giving it to a function called array. And what's happening is it is creating you something like this. Okay, so in other words, more precisely, for the sake of simplicity, think of this as a tray, object 1, object 2, object 3. It creates 3. And what is this? They are homogeneous. You cannot have textual data here. We can only have numerical data. Now, what is the advantage of this one? Data is now a data structure called an array. A list is something where you can have numerical and textual data, whereas array is something where you can have only numerical data. What is the advantage of it? You can ask it, give me the maximum value, and it will give you 3. Okay, it's looking at the values, so you don't have to write a for loop. The function is already there. So that's a simple function, guys. Let's go one step forward. Take a look at this. What's happening? What did we do? Well, we have used np.array. What's it doing? It's creating a numpy array. So in other words, more precisely, Python does not come with arrays. We use numpy package. It's an additional package. And if you recall, we have downloaded Anaconda distribution. The Anaconda distribution automatically includes numpy package in it, guys. Let's go one step ahead. Take a look at this now. Gentlemen, ladies, increasing the complexity a little bit, guys. Let's see if we can understand what is going on first here theoretically, and then we'll jump into a little bit of practicals based on our time. So notice there is a function called np.once. np is going to be the friendly name, and I will also try to explain that. But more importantly, what is this once? You're giving a 3 to it. It's taking an argument called 3. What is it doing? It's creating an array of 3 objects, and then it's putting a 1 inside it. So it's like you're asking, give me 3 objects, put 1 in all the 3 objects and put them together. This is a group of objects is what it is. That is what once does. As the name suggests, it's putting 1 1 1 1. Similarly, zeros, what does it do? It puts 0 0 0 zeros. What's it? This is a group of objects, and this group of objects is filling in with 0. Next you have random.random. What is random? This is 3 random numbers. What does random do? Random is generating 3 random numbers is what it is. As simple as that. So in other words, more precisely, here what we are trying to do is we're trying to get an understanding of what is ones, what is zeros, what is random. NP is the package, random is a module, random is a function. And random generates 3 random numbers is what it is. At a theoretical level, this is what is happening. We'll try to look at that in practical level in a moment after I cover some of the slides, guys. Let's go one step ahead. Now again, take a look at this, guys. What we have is, imagine we created an array 1, 2. And what is it? Here is once. So data is one array and once is another array. What's happening? We filled up 2 ones there. Now notice what is happening here. What we are doing is data plus ones. So we are adding 2 arrays here. If you add 2 arrays, what is happening is, notice 1 plus 1 becomes 2. Notice 2 plus 1 becomes 3. What is this? This is called element by element wise operation. It is called vectorized operation. It is like a matrix like operation is happening. What is that? That is what is special about the arrays. Arrays give you what is called as element by element wise operations. These are called vectorized or matrix like operations. So ideally, in a Java or .NET world, what do you do? Well, you'll take 1 month object-oriented programming language lessons, theory. You'll try to understand. You'll spend 1 month. You'll try to understand what are classes, what are methods, what is public static void main, many other complex things. You learn what is loops, what is for loops, and things like that. What are we doing here? You just create an array, and then you just sum up the two arrays as if they are two arithmetic numbers. What are we doing? We're taking some slightly complex data structures and performing an arithmetic operation. Internally, an element by element wise operation is happening. What you take 1.5 months or 2 months in Java and you learn, we are doing almost in a second day of a lab of a Python. Everybody catching the point, guys? Can you give me a quick yes? That is what they mean by Python is much more simple. It allows you to write this kind of pattern oriented code in a very, very short and sweet amount of time, guys. So let's dig a little bit deep into these things. Let's see what's happening here. Take a look at this. So take a look at this. Data minus ones. Now notice 1 minus 1 becomes 0. 2 minus 1 becomes 1. What is that? Element by element wise operation. Similarly, data multiply. So again, 1 times 1, 2 times 2, 1 and 4. You're getting a new array. And what is this? This is again a division operation. You're getting a new array. Okay, so that's another proof. What are we doing? We're performing what is called arithmetic operations. You're performing arithmetic operations on complex objects. That is what is the power of Python. At the same time, it is the simplicity of Python. The very first time when we look at it, we need to understand this concept. That is the only complexity we're supposed to accept, guys. So let's see what's happening here. Now take a look at this one. What are we doing here? Here, we are now multiplying an array with a scalar. Scalar is a single value. This is like a single value. So what is happening is 1 is getting multiplied with this one, 2 is getting multiplied with this one. That's what is happening, 1.6 and 3.2. So kind of, this one is acting like an array of two elements. If it sees only one element, what is it doing? Well, NumPy is automatically converting it to an array internally, and then it is performing an element by element wise operation. Everybody with me, guys? Quick yes, please. Okay, let's go one step ahead. Take a look at this. Let's see what's happening here. We'll again revisit some of the slicing and dicing concepts. This is where Python is super powerful and super simple, guys. So let's see what we have. Take a look at this. Here's our data. What do we have? This is data, and we have again three objects, 1, 2, 3. So what is data of 0? It's like you're asking, give me the first cup, give me the first object. What's happening? It is following a 0 based index. Data of 1, it is giving you the second object. And so in other words, 0 based index is your mantra. Then come back to the similar mantra, inclusive versus exclusive. Left hand side index is inclusive, right hand side index is exclusive. 0 means 1, 2 means 3. Okay, so indirectly what we're asking is, you're asking Python, give me 1 to 3. But what's happening? It is only going to give 1, then it will give you 2, because the mantra is the right hand side index is exclusive. That's what is happening, guys. So 0:2 is actually you're asking 0 to 1. So it's like you're asking me, give the first and the second one. Then let's say come here. Let's see if I can move this here. Now here comes one column. So let's do a little bit of cleanup. So I come here. So what's happening? 1 colon is, this is 1 means 2 inclusive. Right hand side you don't have anything, that means till the end. So 1 means 2 means it's starting here. 2 till the end is this one. That's what is that one. One more time, the mantra is inclusive versus exclusive is going to be your mantra. Everybody with me? Quick yes, please. Okay, let's go one step ahead. Let's see what's happening here. Put this here. So now, one more time, the advantage of arrays is you don't have to write a for loop or a nested for loop to understand to get the max. Okay, what do you do? Well, it provides a function called max, it provides a function called min, it provides a function called sum. What's happening? All the elements are being summed up and it is giving you the final value. There are lots of such mathematical and scientific functions which NumPy provides it, and it is one of the very powerful packages which is used by the in the Python world and the machine learning world, guys. So that's what is that one. Here is again, now take a look at this, guys, increasing the complexity. This is like a two-dimensional array. Okay, so let's see, come here. Until now we are looking at only one dimension. So here comes the two dimensions. What's happening is 1, 2. So notice 1 is going here, 2 is going here, and then in the next row 3 and 4 is going here. In other words, this is two dimensions. Let's see if we can visualize this, guys. Let's see, for the sake of simplicity, visualize what we are doing is, say come here. You visualize, here is 1, here is 2. Here is 1, here is 2. We'll call this, for the sake of simplicity, a tray. That's what is happening. What is this tray? This tray is this one. Then come here, choose another tray. We'll put 2 more cups, 3 and 4 here. And this blue tray is this internal tray. Go one more. That is the internal tray. Okay, now what is happening is, visualize these two are sitting inside another tray. And this green tray is the dark blue one. That's what is happening. So what is this? This is acting like a tray of 2 trays of 2 cups. Is what it is. A tray of 2 trays. Okay, what is that? That is 2-dimensional. That's what is happening. The outer one is a tray which contains 2 trays. This, here's one tray and here's another tray. For the sake of simplicity, visualize it like that. Everybody with me, guys. Quick yes, please. That is also called a matrix. This is called a double-dimensional array, or this is also called a matrix, is what it is, guys. And let's see what is special about that. Now take a look at this. We'll apply similar functions here. So there is np.once. np.once 3 means, notice what is happening is 3 rows. It took 3 rows and 2 columns is what it is one way to think of it. 3 rows and 2 columns, and put that into a tray and then fill up everything with 1, 1, 1, 1, 1. That's what that once is. But let's say, for the sake of simplicity, we'll visualize like this, guys. Okay, visualize this is tray 1, tray 2, tray 3. 3 trays. 2 means visualize 2 cups in each tray. Then visualize you're plugging in 1, 1, 1, 1, 1, 1, 1. That's what once is doing. And then visualize all these 3 trays are being plugged into one main tray. So what is this one? This is a tray of 3 trays. A tray of trays again. And what's happening? Each tray contains 2 cups. That is what 3 by 2. Okay, so let's see. So that's what is it. In other words, it is also double dimensional. It's a tray of trays is what you can think of. Everybody catching it, guys? Quick yes, please. So in other words, that is one thing I will force you to remember if you don't catch it. For a moment, you force yourself and you try to remember. Okay, guys? Here and there, I will force you. Why, you will understand in the coming up examples, guys. The exactly same thing is happening, but it is getting filled up with the zeros. That's what the zeros is about. And again, random, the exactly same thing, but we are plugging in random numbers inside the blue cups is what you can think of. So what's happening is, it's a tray of 3 trays. So in other words, more precise, let's say 3 trays. In each of the tray, put 2 cups, and then what is that? Oh, that whole thing is being put into a tray. So we have a tray of 3 trays of 2 cups is one way to read it or understand it, for the sake of simplicity, guys. So now let's take a look at the arithmetic operations in a 2-dimensional perspective. Let's come here. We'll run these examples in a bit here, but let me take what we have here. Data plus ones. So there's a 2-dimensional array or a matrix and a 2-dimensional matrix. What is happening now? Take a look at this, guys. What's happening is 1 plus 1, 2 plus 1. In other words, let's say choose this one, 2 plus 1. So 1 plus 1 is becoming 2, and 2 plus 1, sorry, is becoming 3. Oops, let's say this is 2. 2 plus 1 is becoming 3. Okay, so what is this? Again, one more time, an element by element wise operation. 3 plus 1 is going there, and that becomes 4. And then you have 4 plus 1 becoming a 5. One more time, we are proving. It is following a matrix-like operation. In a machine learning world, we also call this as a vectorized operation. This is a touch of linear algebra, algebraic concepts and things like that, guys. Everybody with me? Quick yes, please. Yes, random, as I said, NP is, again, when I explain the syntax, I will explain you. NP is a friendly name of the NumPy package. Random is a module. A package is something which will contain a group of modules and functions. A module is nothing but a group of functions. You can write the function directly under a package, or you can plug it a group of similar functions under a common name called a module, guys. That's what is random. So now take a look at this, guys. Let's see, let's increase the complexity here. So now what we are doing is we are taking the data, which is a two-dimensional, and then we are adding it to a one-dimensional, one. Okay, so what is happening is, notice, imagine this is a tray. Visualize this tray is getting copied and pasted here, copied and pasted here, copied and pasted here, and the element by element wise operation repeats. So what is it that is being automatically done? What are we doing? We are performing an arithmetic operation between two complex objects, and what is happening is it's kind of doing that one. It's kind of assuming, it's giving one row, it's associating one row with each of them. So I come here, I think the right hand side is slightly less visible. And let's see, everybody okay with that? Quick yes, please. Matrix addition, yeah. If you go back to the little bit of school and things like that, a matrix like addition, matrix like operations are going on. These are some of the things which are happening at a mathematical level. We use the algorithms or we perform the NumPy operations, guys. So there it is again. So now let's say this is an example of a dot product. Again, let's see. Visit it quickly. So there it is. We have this is acting like one row, three columns, and we're doing a dot product. So when you do a dot product, there you go, you get that result. So what's happening? 3 and 3 is taken out 1 by 2. Let's say I come here. So one row is getting picked up from here. Two columns are being picked up. That is becoming a one row and two columns. That's coming up there. So go back and have a look at a dot product formula and things like that. That is just a quick thing I just wanted to give you. So let's take another example here. Snap it. This here. This here. Let's see what's happening here. Sum. So one more time, what we are doing is we are doing a sum of this one. So in other words, we're taking one array here, another array here, and what are we doing? First, we are multiplying these two. Okay, so in other words, let's say we are taking this one, we are performing a multiplication. So element by element wise multiplication is happening. And then again, we're doing a similar thing here. Take this one, and 1 times 10, and that's creating that one. And now what's happening is 3000, 30201. So in other words, this is this one, this result is this one, that is what is coming up. So that's becoming one row and two columns, 1 by 2. That's what is 1 by 2. Okay, guys, let's say there you go. If you want to look at the complete result. So that's again, I'm just giving you a touch of the matrix like operations there. Let's see what else we have. So now take a look at this, guys. Back to slicing and dicing. This is called slicing and dicing. This is where Python looks super simple and yet it is super powerful. So one more time, remember, it follows a zero-based index. When you move from left-hand side to right-hand side, it follows a zero-based index. So that is your data. That's a tray of 3 trays. Tray 1, tray 2, tray 3, 2 cups. In each tray you have 2 cups. Now what you're asking is left-hand side, 0, 1. So what this is doing is, let's see, it's actually, it's like saying, you say 0, 1, you're asking it go to the first tray, first row, give me the second cup. So that is going to be 2. That is going to be 2. You will only get that. Okay, that's syntax. If you put a comma, you're extracting one item. If you're extracting one item, that is called indexing. But let's say you give 1:3 again, inclusive versus exclusive. 1 means 2, 3 means 4. So which means you're asking it, give me 2 and 3. So what it is doing is it's actually giving you the second tray and the third tray. The fourth tray it is excluding. It doesn't have fourth one, but more precisely, here is the second tray, here is the third tray. That's what it is doing. Then let's see what's happening here. So 0:2. So whatever is in the left hand side will become a row-wise operation, guys. 0:2 means 1:3, inclusive and exclusive, which means 1 and 2. So pick up. So it's like, let's do a little bit of cleanup here. So pick up the first tray, pick up the second tray, and then what you're doing is you're giving a 0. So what's happening in the first one? Pick up this one. 0 means 1. So in this tray, that becomes 1. This becomes 1. What is this, guys? This is called slicing and dicing. In a Java and a .NET world, we'll write maybe 10 to 15 lines of code, a class, method, loop, a nested for loop, and things like that. What is this? This is like a watermelon. More precisely, this is like a watermelon. What are we doing? Imagine some friends come to our home. What are we doing? We're kind of taking a piece of it and giving each one piece using this kind of syntaxes. Everybody with me, guys? Quick yes, please. These are the syntaxes. There are a lot of combinations. We cannot cover everything, but I'm trying to give you a little, which will give you a decent idea, guys. Okay. So again, one more time, notice what is happening. You ask a double dimensional or a matrix, what is the maximum? It's picking up the max value. Here it picks up the min value, and sum is summing up everything. We don't have to write loops, nested for loops, and things like that, guys. So now here comes a slightly deeper one. It's a simple one, but slightly deeper one. Let's see what that means. So take a look at this. Here is our data, and what are we doing? We're saying axis equal to 0. Axis equal to 0 means it performs what is called row-wise operation. Column-wise operations. By default, it performs column-wise operations. So when you say, give me the max. So let's say, give me the max. What's happening is, in each column, it's picking up the max value. It's picking up the max value. So there is the max value. Here is the max value is what you're getting. They are coming in as a single row of 2 columns. So what is axis equal to 0? It performs column-wise operations. Okay. Say axis equal to 1. It is now performing row-wise operations. Notice in these two, it's picking up 2. There is 2. Then it goes to the next row, picks up 5. Okay, then it goes to the next row, picks up 6. So in other words, axis equal to 1 means you're explicitly telling it perform row-wise operations, not column-wise operations. Everybody with me, guys? Quick yes, please. Okay, so let's see what else we have. Oops, come here. Okay, so there is data. What do you think is T here, guys? What is T doing here? What is dot? Transpose. Make the rows as columns and columns as rows. As simple as that. Let's go here. Take a look at this. Now here comes a slightly tough one. We'll revisit these things maybe in the exercises again, guys. If you miss something, I will show you. We'll be performing some exercise examples today and probably tomorrow also, guys. So let's see what we have here. Take a look at this. And come back here. So now what we have is, we have data which is like an array. It's like a group of 6 objects there. You say reshape. What is reshape doing? It is converting it into 2 rows and 3 columns. So there's tray 1, tray 2, 3 cups in each one. 2 trays and 3 cups. What is that? That is reshape. 6 of them, 2 times multiplied by 3 is 6. Okay. Pardon me. And we can also say 3 by 2, 3 trays and 2 columns is what is happening. So if we do a little bit of cleanup, when we say reshape 2, 3, notice it is filling up row-wise. When you say reshape 3, 2, notice again it's filling up row-wise. Goes in that direction. So by default, it is performing row-wise fill is what is happening. Another thing, you don't have to by heart it. You don't have to remember, but it's just a quick observation is what it is. So what is reshape doing? Reshape is shaping it back into custom number of rows and columns is one way to think of it. A slightly important one, but something to be kept in mind. Everybody with me, guys? Quick yes, please. Okay, let's go on. Now take a look at this one more time. Increasing the complexity, guys. Let's see. Okay, let's see. Okay, I think I'm almost nearing the end of the slides. So take a look at this. What do we have? This is a three-dimensional tray. A bracket there, another bracket there, another bracket there. So this is like three-dimensional. 1, 2, 3, 4, 5, 6, 7, 8. This is like it one double dimensional, two-dimensional, another two-dimensional. More precisely, if you come back here, let's say come not here, back here, we realize this to be something like this. So this is like one tray here, and this is, let's give this one. These two are in a blue one. Then what you do, we'll say here's a blue one, and behind the scenes here's a blue one. Let's put this in a green one. Okay, now what you do, these two are in a big tray. So yellow is one dimension. It has two trays, and what of them have? What do they have? They have the pink trays. So that is the second dimension. This is the third dimension. This is the second dimension. This is the third dimension. That's like three dimension. Dimension 1, dimension 2, dimension 3. That's a three-dimensional one. Okay, guys. And let's see why it is important. So there it is, guys. One more time. If you want to fill ones, zeros, random, what can we do? We can just give four, four rows, three columns, and that's like becoming two dimensions. So you can keep on increasing the number of dimensions like that. This is probably not very straightforward to interpret it. 4, 3, 2. So 4 trays, 3 columns, 2 cups. 3 columns and two of them. That's going to be a little tough even for me to simplify it a bit more, guys. But I'll see if I can simplify it when I cover a few exercises. So that's a little bit of NumPy theoretical understanding, guys. Now let's see, get a touch of a practice for today, a little bit of practice for today. So let's come back here. Here's a list, simple list. Let's say maybe at this stage it might not be very simple for you, but take a look at this. Here is a list, say underscore list. It has 5 objects inside it. Now come here, take a look at this. Here is underscore array 1D. We're giving, you can give whatever name you want. For the sake of simplicity, I'm calling it underscore array 1D. Notice it gives you an error. What is happening is it is saying, hey, I don't know what is this NP. What is this NP is what it is asking. So what should we do? We should say import NumPy. Okay? And then try to run it. Notice it gives you an error. What's happening? When you say import NumPy, imagine you're a carpenter. This package is like a toolbox. What are the functions inside it? Functions are like screwdrivers, the different tools. If you want to use a toolbox, if you want to use a screwdriver or a hammer inside a package, what you need to do is you need to open it. We opened it, okay? But what did we do? We did not give a proper name. What we should do is we should say import NumPy as np. Now take a look at underscore array 1d. There are 5 cups. What is the difference? It looks like list object, but at the outside it says it's an array. What is special about an array? An array can have only numerical data or textual data. Okay, guys, the list is heterogeneous. An array is homogeneous. Yes, please. Cool. Okay, so let's come back here. And so here is just another thing to keep in mind, guys. Let's say try one more time np.array. What can we do? We can also explicitly say numpy.array. This will work. But generally, we give that friendly name. This is an alias or a friendly name. You don't want to type keep on typing the full name and things like that. So we generally use that friendly name as a shortcut, guys. We'll call that as a friendly name. That is the NumPy. So what did we do? We have converted a list into an array. We're saying, hey, when you convert it to an array, you're telling Python, make sure only the numerical data or only textual data is inside there. Now take a look at this, guys. I have created what is called Anjum. Anjum is the name of a person. You can give whatever friendly name you'd like. Okay, so here is Anjum. Now what do? You say, here, creating an array using Anjum keyword. or more precisely the friendly name. But in the real world, we will not suggest use names like that. If you have a senior data scientist or a professional sitting there, they'll advise you not to use names like that, not to use your personal names. The standard practice, give the abbreviations and things like that is what it is. So let's come back here. Ask what type, what is a list? When you say type, you're asking Python what kind of an object. It says it's a list. Then ask what kind of an object is this. Notice it says it's numpy.nd array. What is nd array? It is more precisely saying it's an n-dimensional array. What is an n-dimensional array? It has multiple dimensions. It's a multi-dimensional array. It's like a matrix, more precisely, is what it means, guys. Everybody with me? Quick yes, please. Like a NP is like a nickname. Yeah, that's a good one. Okay. So now take a look at this, guys. Maybe a last exercise, and I'll take some questions and I'll leave you for today. Take a look at this. Underscore list plus 2. So here is underscore list. We have 5 objects there. You do a plus 2, notice it will give you an error. What does that mean? What we are trying to do is we are trying to perform what is called an element by element wise operation in a list. And what is happening, a list does not support the element by element wise operations. They do not support matrix like operations. But come here, take a look at this. Underscore array 1D plus 2. Notice an array supports matrix like operations. You can also perform arithmetic operations, multiplication, say here's a division, and what else we have? Here's a subtraction. What is that? That is the difference between array and a list. Everybody with me, guys? Quick yes, please. Okay. So, gentlemen, ladies, what we'll do is, for today, what I want to do is, I want to stop it here and I want to open up the floor for a few minutes for a few questions. We'll continue the journey. Probably this week, the next 2 days, I'll be focusing on some basics of Python, guys. I want you to stick with me until I touch a little bit of object-oriented programming, because for machine learning examples, case studies, and things like that, we need a touch of object-oriented programming, guys. So just bear with me if you're already familiar, and that a lot of guys here who are not coming from programming background, it will be helpful for them. Okay, guys, let's be sportsmen. Let's exhibit some sportsmanship spirit, and we'll try to do that, guys. Homeworks and assignments, okay. I'll keep that in mind. I will be passing on some homeworks, and will be sharing it with you in the coming up days, guys. Normal array and numpy. There is nothing like a normal array. Snehita. Python does not have arrays. They say Python does not have arrays. There is only numpy arrays. The numpy arrays are like normal arrays. And what do? NumPy is an additional package that is outside Python. But because we install Anaconda, it comes installed with Python. So in other words, short answer, let's put it like this, Snehita. Think of NumPy arrays are the normal arrays in Python. Okay. pip install NumPy. Yep, pip install is how you install. And we'll install 1 or 2 packages in the coming up days, guys. Okay. Explain install. Pip install, that's how you install a package, guys. So if you come here, let's say exclamation pip install NumPy. For me, it will say it is already installed. Give it a moment. Exclamation is telling this is actually a Windows command. When you do it in Jupyter, what happens is you're telling Python, hey, install this package. So it is connecting to a central server and trying to download that package. That package is a group of functions and things like that, guys. So now I already have it installed here in this one. It's saying, hey, it's already installed, so I don't need to connect back to central server and things like that. That's what that means. Is there any limitation on textual data for variable? No, for textual data, I don't think there is any limit. 1D array without, no, you cannot create 1D array. Or a short answer, just one. If you want to create a one-dimensional array, you create a list object with a group of objects there. that will act like a 1D list, but remember it is heterogeneous. Material, yeah, point taken. You have to. It's been a pretty busy week for me, guys, but we'll share it maybe by the end of this week. Purpose of NumPy. Vishnu, it gives us a lot of additional packages and, or more precisely, functions, mathematical and scientific functions. Behind the scenes of machine learning and deep learning, they are all using NumPys and Pandas heavily. So it is always good to have a kind of an idea. They use a lot of scientific and mathematical functions which are coming from these packages. That's why we're explicitly spending some time in the NumPys and the Pandas. Okay, NumPys and Pandas are one of the most important data structures for in the AI world and the data science world. Okay. NLP, I'll talk in the coming up days, guys. Let me go one step at a time. It stands for Natural Language Processing. It's about finding patterns, hidden patterns in textual data. We'll first work with the um, numerical data, then we'll work with the textual data in the coming up days. Lists are not dominant or predominant in data science. Arrays and pandas data frames are more dominant. Pandas has another data structure called data frames. We're coming there. That is the next in the coming up sessions. Data cleaning techniques, yes, those are all the part of the machine learning concepts, guys. So it's if I touch them, it requires a lot of background. So let's take it one step at a time. Lists and tuples. Tuples are lists, but you cannot modify a tuple. List is something which we can modify. Examples are on the way. Okay, NumPy has lots of functions, guys. So a quick look here. If we come back here, you can say help of NumPy like that. Notice. Give it a moment. No. Let's say dir of NumPy. There it is. Hold on. These are all, some of them are constant. Some of them are, these are generally something starting with a small as a function. These are all the functions A, B, C, D. They're all sorted. Lots of mathematical functions and things like that. We don't need to know everything. There are some important we'll be touching. We'll try to get familiar and they will get us going. Okay. Okay. The freshers and things like that. What you also try to do is try to also do a little bit of read up of Python basics, guys, and that will help you in the time for the time being. Type conversions and mathematicals. Type conversions. So Ramkrishna, type conversion is where we are converting an integer to string, string to integer. So numeric data to textual, textual data to numeric and things like that. I've just shown you a couple of examples, I think, in the previous session. Okay, placement assistance. I think that I will leave it for the AP skill development team. Today's class is important. Who's that? Kishore. Yes, it is important. NumPys are very important. The next one is going to be these basic data structures will help you in simplifying. 432. So four rows, 3 columns, and is one, one tray. Let's assume another tray with 4 rows and 3 columns. So you have 2 of them. So it's like what do we call that? Rows, columns, and the last one is so I'm sorry, guys. I'm trying to recall. It is called. Pardon me. Sorry about that. I'm trying to recall that, guys. Shoot, sorry about that. I can't recall it, but there is a special this thing which we call it. Is it a step? No, it's not a step, guys. You have to give me some time, and I'll see if I can. Slicing and dicing, the applications is data science only. When you do machine learning, that's where we will be. Slicing and dicing. Can we encrypt and decrypt? Yes. There are again separate packages for encryption and decryption. Access equal to 0 means it's performing a column-wise operation. Different values. Can we give? No. NumPy arrays generally have homogeneous values, guys. And let's see. Feedback. Okay, that I will leave to Mansa. That also attendance I will leave it to Mansa, guys. So here is my email. I just shared my email, guys. Okay. Yeah, we'll look at a few case studies / projects. Dictionaries. Dictionaries also will talk. Yet to be covered, guys. So, okay, gentlemen, ladies, 8:45. Forgive me, guys. I have to get on to another meeting. So I'm going to be wrapping a little bit early. Mansa is sharing the feedback form. Please try to share your feedback for today. And I will sign off. Mansa will be here for a few minutes. And she will handle it from here, guys. So please forgive me for today and allow me to sign off. You guys take care, stay safe, and keep learning, guys. Okay? Signing off for today. I will see you tomorrow again. Thank you and bye for now.
Thank you, sir.
Thank you.
So, participants, there is a question that attendance is mandatory. You should attend all the sessions. You will be having a weekly assessment test. So, based on your attendance and performance, you will get the certificate at the end of this training. I'm posting the feedback link again in the chat box. Please check it and fill it. If you have any more questions, you can add it in the additional comment section in the feedback form. The same will be shared with the resource person. We will let you know about the date. We'll let you know about the test soon. If you are a student, mention the college name, or if you are working, please mention the organization name. Okay, non-EP people also can attend this session. If you are not working, if you are a fresher, fill your previous college name. Like yes, feedback. Filling the feedback form is mandatory. Regarding the material, we'll talk with the resource person and we'll let you know. Please fill the previous organization details. It is 4 weeks class, 4 weeks training program. We will let you know about the assessment tests. So you are repeating the same questions. If you have any more questions, please fill it in the additional comment section in the feedback form. So thank you all.